Hey guys, welcome back. So we had our first day of parent-teacher conferences today, and I thought of a funny story that I wanted to share with you guys. So if you'll allow me, we'll start out with a story, and then of course I'll give you guys a link so you can skip it if you want. But this is going to be a good one. You're going to like it. All right. So 2 years ago, I was dressed up nice for parent-teacher conferences. One of my students said, "Mr. Murphy, what was it like date night? What do you got a date tonight or something? What are you dressed up?" I said, "Yeah, I got a date with your mom." I know, and the crowd goes crazy. All right, so um, anyway, he walked right into it, so I couldn't like not say it. But anyway, so parent-teacher conferences went really well. You guys have some very lovely parents. They care and love you guys very much, of course. They have to by law, and they're very proud of your accomplishments and that you guys are working so hard and succeeding and doing so well under these conditions and distance learning. So that's pretty much what we talked about in almost every single parent-teacher conference. And anyway, it was very nice to be able to talk to human beings instead of talking to myself in my room all day long making these videos. So anyway, the next day after that, um, so anyway, I had my date night anyway, and the parents they sign in whenever we used to do our parent teacher conferences in person. Parents sign in with in a signage sheet, and they give me their contact information so I can get a hold of them later. And the next day, one of my students in that class, a different student, said, "So, Mr. Murphy, how was your date night?" And I said, "Oh yeah, it was great. You know, I guess it was pretty successful. I got a bunch of numbers, and I held up the sign-in sheet with all the with all the email addresses from your parents." And then one of my students said, Trenton in the back, of course, he said, "Mr. Murphy, that was my dad." So he got me on that one. Anyway, so a fun story, fun joke. Anyway, so I enjoyed for you guys who have been going to the Google Meet, so I've gotten to know a little bit better. I enjoyed telling your parents about all the crazy and fun things and great advice, life advice, and stuff that I have been able to share with you guys. So your parents are really cool. You may think that they're annoying and they don't let you have any fun, but they really do care for you, and they're really cool people. So, and they all like me, so that's good. All right, so yes, it was really fun, and thank you guys for working hard for me and for all the compliments. I got a lot of compliments from you guys and from your parents, so thank you. I work really hard for you guys, and I love what I do, and I can't wait to see you guys in the classroom. I'm getting really excited of just the prospect of that. So for you guys who are able to return, I'm really looking forward to it. All right, without any further ado, let's get right into this practice test. So Wednesday, tomorrow, we will be taking the test. So all of your homework should be turned in by then, and I'll have you guys take the test for Unit 3. So far, we have 37% of you guys who have not taken the test yet. So if that's one of you, or the practice test, make sure you don't watch this video until after you take the practice test. The whole point of the practice test is to give you an idea of how you would do if you took the test today. So take the practice test, fill it out just like you would a homework assignment with a PDF. Then submit it with on Mastery Connect. Submit your answers by using your phone or your iPad or whatever, and then you'll get your score and you'll see how you did. And then you can watch this video and you can go through with your PDF and see what you guessed or what you answered and see what you did wrong. So I'll be discussing that. So let's go ahead and get started without any further ado. So number one, this was 21% of my students missed this one. So which of the following are pair of skew lines? Well, we have to remember what are skew. So we have parallel, perpendicular, and skew. So parallel lines are coplanar lines, meaning you're on the same plane, that do not intersect, and they go in the same direction, right? We also learned that on a Cartesian plane, parallel lines have the same slope, and that's why they never intersect, because they keep rising and running at the exact same rate. Then we have perpendicular lines, which are coplanar as well, but they do intersect, and they intersect at a special right angle. And we learned that they have opposite reciprocal slopes, where we change the sign and flip do the reciprocal, flip the numerator and denominator. But skew lines are similar to parallel lines, that they don't intersect, but they are non-coplanar, meaning one of them is twisted. So for a pair of skew lines, let's look at the first one, which would be JM and PQ. So JM and PQ, if you notice, those are actually going to be on the exact same plane. And if I draw a diagonal line connecting here, you can probably see that plane. It's going to be a diagonal plane cutting across here, across the cube. Okay, so they do intersect. They do not intersect, but they are on the exact same diagonal plane, and so they are actually parallel to each other and not going to be skew lined. So what we would need to do is need to twist one of those. So if they still do not intersect, but they also are not parallel. So that's not going to be our answer. So instead, let's look at this one right here. So what about PK and PQ? So PK is going to be the line in the back. PQ is also the line in the back on the bottom here. These two do intersect, so they're not parallel, they're not skew, and these are actually going to be perpendicular because they intersect at a right angle. So that's not what we're looking for. So it looks like 4% of you guys guessed that one. What about JM and RQ? So JM and RQ. So these are the ones that we are looking for. So JM and RQ. So these are not the droids you're looking for. JM and RQ. I'm in a good mood today. Those two are not on the same plane, right? One of them's on the front surface, the other one's on the right surface, and they also don't intersect. So it's like if we took two parallel lines like ML and RQ, if we took those two, ML and RQ, and then we twisted one of them so that we had JM, now they're no longer coplanar because they're not on the same surface and they do not intersect. So that'd be correct. And then the other one that we had would be JN and LQ, which are going to actually be parallel because they're both just going straight up and down. So that would not be it either. All right, so what lines are parallel to JM? So parallel to JM would be KL in the back, and then PQ and NR. So that's that, pretty simple. Let me pause the video and actually fix the file real quick. All right, so number 3 says which lines are perpendicular to JM. So perpendicular means they're going to intersect and intersect at right angles. On a cube here, any lines that do intersect will intersect on right angles. So perpendicular to JM would be JK, so those are going to intersect at right angles. ML on the back here, that's also going to intersect at a right angle. And lastly, MR, which is going to intersect at a right angle on the front face. So the other ones, most of you guys got that one right, only 17% got it wrong. So be careful there. In the following picture, which angles are corresponding angles? So the first one is looking at 4 and 10. So 4 and 10, I agree, they're both corresponding in the sense that they're both in the top right hand corner of those two of the two lines, but the problem is that they're not on the same transversal. So if we did 4 and 12, those would be corresponding, because they're both in the top right location across the transversal D. If we did 4 and 2, those would be corresponding as well because they're both in top right hand location across the transversal A. But if we go from 4 to 10, we have to cross 2 sets of parallel lines. So they're not actually going to be corresponding angles. So be careful about that. That got some of you guys. And then 7 and 8, those two are actually a linear pair. So they're a pair of angles, adjacent angles that are supplementary that add up to 180 degrees. So 7 and 8 would not be it either. And then what about 2 and 10? So I think I can actually do that one. So here we have 2 and here we have 10. Okay, that's fun. All right, so top right and top right here, they are corresponding because they're in the top right location, the same location across the same transversal of C. So if lines A and B were parallel, then we would know that 2 and 10 would have to be congruent. So those are corresponding angles. That's the one that we're looking for. And then some of you guys didn't like that one for some reason, but that was the correct answer. All right, so using the information in the following picture to find the measurement of angle P. So here we can actually jump across to the top right and the top right because we have 2 sets of parallel lines, okay? But I'm going to do it one step at a time, okay? So if the top right is 97, the corresponding one here would be 97. That's the top right. And then you might notice that P and 97 are both same side exterior, which means they are going to be supplementary to each other. Okay. You could also just move it down here. So top right, so move the corresponding angle down here. So corresponding from here to here, and then another set of corresponding angles from here to here. Okay. That will now tell us that these two are a linear pair, and so they're supplementary, and the supplement of 97 is going to be 83. So our correct answer would be B as in Bravo. Most of you guys that got it wrong thought they were congruent. Be careful. They're not actually. I don't know what you were thinking. Maybe you were thinking they were alternate exterior angles or something like that. But just move the corresponding ones down, and then you'll see if they're going to be congruent or if they're going to be supplementary like they were in this case. All right, number 6, what's the value of x that makes M and N parallel? So M and N are here. Here's our transversal across here. This tells us that it's a right angle, right? So that's 90 degrees, no big deal. And then here we have 15x. First of all, what kind of angles are we dealing with? One is on the right side of the transversal, one's on the left side, so they're on the alternate side, and they're both on the exterior of the parallel line. So these are going to be alternate exterior angles. What's special about alternate exterior angles? Well, they are congruent to each other. In fact, all of our angle pairs are congruent except for the same side ones that are same side supplementary, like same side interior and same side exterior. So now that I know they're congruent, I can set them equal. So 15x is going to be equal to 90 degrees. Then all I have to do is divide both sides by 15x, which will leave me with x is equal to 6, which will be our final answer, which is C as in Charlie. Most of you guys got that right. Good job. Proud of you. Way to go. Another thing you could do is you could also, if you're not sure, you do need to know your angle pairs by now, but if you're not sure if they're congruent or supplementary, you can always just move with corresponding vertical angles and check. So bottom left, 15x is going to be vertical with the 90, so you can, of course, set them equal and solve. All right, number 7, what's the value of x that makes J and M parallel? So these are both corresponding angles, so top left, which means that they should be congruent to each other if the lines are parallel, right? So set them equal. 2x is going to be equal to 40, divide by 2 on both sides, which is going to leave us with x is equal to 20 degrees. And that should be our correct answer. Again, most of you guys got that right, so good job. Keep up the good work. Number 8, P and Q are parallel, so therefore you can find the value of x. All right, so on this one, we have, we want to know what kind of angles we're dealing with. They're on the same side of the transversal, both on the left side and the exterior of the parallel lines. So these are going to be same side exterior, SSE. And same side angles are same side supplementary, and so they add up to 180. So we can add up the expressions, 3x plus 18 plus 6x, and set it equal to 180. Again, guys, make sure you're setting up these equations, not just trying to work backwards or doing it in your head. I need to see you set up the equations, okay? So combine your like terms would be our next step. So the 3x and 6x are on the same side of the equation, so we can add them together. That's going to leave us with 9x plus 18 is equal to 180. Then we want to get the x by itself, so we need to get rid of this plus 18. We undo addition with subtraction, so subtract 18 from both sides, leaving us with 9x is going to be equal to 162. Last step, we don't want 9x, but just 1x, so we undo the multiplication with division. So we divide both sides by 9 with the division property of equality, which actually leaves us with 18. So our answer is x is equal to 18, which is 69% of you guys got that right, so good job. And it looks like the most common mistake would be x is equal to 6. That's probably if you set them equal to each other. Yes, that is if you set them equal to each other. So do be careful. A lot of you guys mess that up. You will notice on the entire, pretty much on the entire unit, either they're going to be equal to each other or they add up to 180 degrees. So be careful. Do you set up one way or the other way? I guarantee you that if you set up the wrong way, that'll be one of your answers as well, just like this one was. So do double check. And in fact, if you're not sure, you can always move your corresponding angles, like move the 6x up, or you can move this angle down here, and you'll see they're not exactly the same. If they were vertical, then they would be the same, but they're not. They're a linear pair, meaning they're going to be supplementary and add up to 180 degrees. So do be careful. 28% of you guys got tricked on that one. Just make sure that you move your vertical angles to see if you set them equal to each other, or you add them up and set them equal to 180. All right, 9. ABCD is a trapezoid. What's the measurement of the angle BDA? So BDA is going to be the angle marked with the x. So we're trying to find the value of x. So on this one, it's a trapezoid, so we have one set of parallel lines. So we can use alternate interior angles there. So if we look at this line here as our transversal, let me color code it just so it's easier to see. The alternate interior of 107 is going to be this angle right here, which also has to be 107. So we know that because they are alternate interior angles. Which I'm not sure if they're alternate interior angles, which means they have to be congruent to each other. Now you'll notice we have 107, 37, and x. What do we know about these three angles? What do they add up to? Straight lines, so they're supplementary. They add up to 180 degrees. So you can add them all up and set them equal to 180. Combine your like terms, it's going to give you x plus 144 is 180. Then we subtract 144 from both sides, leaving us with x is equal to 36. So this angle here has to be 36 degrees. So that would be our answer of B as in Bravo. Another way that you can solve this problem, instead of doing 107, you could also move the alternate interior for x. So looking off this transversal here, just another way of doing this problem. We know the alternate interior with this transversal would be this angle right here, so this has to be x. And then we have a triangle. If we see our triangle here, you'll notice triangles have to add up to, the interior angles add up to 180 degrees, so they're supplementary, the same, right? So x plus 107 plus 37, just like what we have here, also has to add up to 180. So there's multiple ways of doing this. In fact, embedded in this problem is the proof for why triangles' interior angles add up to 180 degrees, which I showed you on one of our assignments too. It's kind of a cool proof. All right, number 10. In the figure, if lines R and S are parallel, then what do we know about the value of x? Well, first, if I look at the 6x and the 12y, if R and S are parallel, those are corresponding angles, so I could set them equal. And if I do that, I would end up with 6x is equal to 12y. But can we solve for two variables at the same time with one equation? No, we could do substitution or elimination if we had two equations involving those two, but we don't have that. We could make one by setting these two equal to each other as well, but then you might as well don't do it. So that's just a rabbit hole you don't really want to go down, and it's not necessary. So let's look at the two angles or expressions that have the same variable, like the 6y and the 12y. Okay, so how are those two angles related to each other? Well, if you notice, one's on the left side of the transversal, the other's on the right side, so they're alternate side and the exterior of the parallel line. So these are alternate exterior angles, and we know alternate exterior angles have to be congruent to each other. So we can set those two expressions equal to each other. They're not supplementary, they're equal. So then we can solve by subtracting 6y from both sides, leaving us with 72 is equal to 6y. Then we divide both sides by 6, leaving us with y is equal to 12. Now that's not our answer, and most of you guys that got this wrong, you saw 12 as one of your answers, like done. They don't want us to solve for x or y, they want us to solve for the value of x. So once we have the value of y, we have to plug it into the equations or to the expressions in order to be able to solve for x. So it doesn't matter which one you set them you plug it in for, you'll get the exact same value, but it's easier just to multiply it by 12. So I'm going to take y is equal to 12, and I'm going to multiply that times 12, so I get, this is going to be equal to 12 times 12, which is 144 degrees. Now that I know that this is equal to 144, the corresponding angle over here also has to be equal to 144. So I can set up that equation and say that 6x is equal to 144. You get the exact same thing if you plugged it into the expression up here, and then you can set the vertical angles equal to each other. So 144 is equal to 6x. Divide both sides by 6, and you end up with x is equal to 24, which is the actual answer that we wanted because they asked for it, what was the value of x. So again, really simple. Just make sure that you're reading the questions and not rushing through the problem. Most of you guys got tripped up by that. There will be something we call like an intermediate step or an intermediate answer, and typically if I'm writing the test, I'm going to make that one of the answer choices because sorry. Number 11, find the value of x in the following figure. That's why we're going through this together, so that you don't get messed up with the problems, the tricky questions and stuff like that. So you will see kinds of stuff like that on the ACT and other higher level math tests. So it's important that you catch yourself making ththose mistakes, which is good, so that you can learn from them. Find the value of x in the following figure. So again, parallel lines. So we can do alternate interior angles. So this, we did our transversal here. So let me color that. I like that color, orange. It's growing on me. And you know, we're pirates, so it makes sense. All right, so if this is 35, the alternate interior up here is also going to be 35. And now we can solve for the missing angle because we have a triangle. Do you see the triangle? Now do you see the triangle? I should have chosen a different color because I didn't realize that I was going to do that. Okay, so you see the triangle? Well, some of the interior angles of a triangle, which we already proved earlier, has to add up to 180. So that means that you find the supplement. So 40 plus 35 is going to be 75, and then we subtract that from 180. So 180 minus 75, which is going to leave us with, let's see, that's going to be 105. Okay, so this angle in the middle is 105. Okay, good. But that's not the angle we want. We want to know what is this angle here, which is the supplement of that, because they add up to a straight line. So the supplement of 105 is going to be right back where we started, which is going to be 75. Okay, so our answer is C as in Charlie. Most of you guys that got this wrong, you found the supplement, but you know, I'm not sure what you did, but you know, just fill in the diagram and you'll be fine. All right, number 12. Which lines of any must be parallel in the following picture, and explain why? I think this question was supposed to say if 1 and 2, angles 1 and 2 were supplementary. So if I didn't fix that on the practice test and it didn't make a lot of sense, my bad. So it'll be fixed on the test, trust me. So if 1 and 2 are supplementary, then which lines have to be parallel? So when we're given two angles here, the first thing we want to do is find what's the transversal that's relating those two angles. So these two angles are on the same line, and that transversal is going to be line H. So if H is a transversal, what two lines are in question for being parallel? Well, the two lines that are being related by 1 and 2 are going to be lines J and lines K. So those are the ones that would be parallel. And then the next thing we look at is if these are same side interior angles, and they are because they're on the same side of the transversal and they're both on the interior of the parallel lines, then that means they must be same side interior, same side supplementary. And if they tell us that measurement of angle 1 plus the measurement of angle 2 is equal to 180. So if they tell us that they're supplementary, then that means that the lines have to be parallel by the converse of the same side interior angles theorem. So we're going to say that J and K are parallel by the converse of same side interior angles theorem. So a correct answer would be A. All right, good. The reason it's not G and H, and be careful, is because you notice how these angles have nothing to do with line G. We have no idea what angles are being formed by the intersection up here, okay? So it's not relating G and H to each other. It's actually, H is a transversal, it's relating J and K to each other. And that's going to tell us whether or not those are going to be parallel. All right, number 13, determine if A and B are parallel. So mark those. Those are going to be our parallel lines, or the ones that we're testing to see if they're parallel. They're the ones in question. So I need two angles that relate these two lines together. So, and they have to be on the same transversal. So the transversal I'm going to use is going to be transversal C because it has these two angles that are on it. I can't use D because I don't have an angle down here, okay? So I'm not going to use this 91 up here. It does not relate because it doesn't have another angle down here that I could relate to it, okay? So these are the two angles that I'm going to look at. I wonder if I can actually, yeah, so there you go. Those are the two angles that are in question. That's our transversal. We need to know what kind of angles we're dealing with. They're on the same side of the transversal, the interior of the parallel line. So once again, we have same side interior angles, which are going to be same side supplementary. Oh, my handwriting is gorgeous. By that, I mean it's disgusting. I know. So add those two angles together. Do they add up to 180? Yes, they do, which means they are supplementary. So that tells us that lines A and B have to be parallel. So the answer is yes, by the converse of same side interior angles theorem. So there aren't any corresponding angles. So that would be true if the angle down here was shown to be 91, but it wasn't a corresponding. Oh no, you can see my trick. They weren't corresponding because they're same side interior angles. So be careful. I'm not sure why so many of you guys were tricked up on that. And these two angles up here would actually be alternate interior. So yeah, be careful. Corresponding are going to be in the same location, like bottom right and bottom right down here. So it is true that this would be 89 down there and this would be 91 up there. Okay, so that's how you can move them corresponding. And that was, believe it or not, that was the most missed problem. So, hope you know how to do it now. All right, moving on. Number 14, with the given information, determine if C and D are parallel. So now we want to relate C and D to each other. So I need a transversal and two angles that are on the transversal that's going to relate C and D. So in this case, we're not going to use this angle here because there's no angle on this side of it. So the transversal we're using is going to be line A, and the two angles that we are going to be relating to each other are 91 and 89. Now if we look, we need to know what kind of angles those are. So they're both, well, sorry, they are on the alternate side of the transversal, and they're both on the interior of our parallel lines in question here. So they're going to be alternate interior angles, and alternate interior angles have to be congruent to each other. Are these two congruent angles? No, they're 89 and 91. They're close, really, really close, but not quite congruent, meaning these two lines, C and D, are not going to be parallel, and we can prove that by the converse of the alternate interior angles theorem. So our answer is no, because the alternate interior angles are not congruent. Again, not the corresponding angles, but rather the alternate interior angles. I don't know if you guys are just charlieing out because you're in doubt or something, but these are not corresponding. If it was corresponding, it would be like this angle right down here. So bottom right and bottom right. Okay, now you could technically move to the vertical angle down here, then you could see the corresponding angles are not, but that's an extra step. Just go with whatever angles that they're showing you. In this case, they're showing you the alternate interior angles, so you're not necessarily wrong, the corresponding angles aren't congruent, but that's not the angles that were shown without doing an intermediate step. Okay. All right, 15. Which lines of any are parallel must be parallel if 4 and 7 are congruent. So 4 and 7, again, what kind of angles are we dealing with? We've got the alternate side of the transversal. They're both on the interior of the parallel line, so these are going to be alternate interior angles. What do we know about alternate interior angles? Well, alternate interior angles must be congruent. And are they congruent? Yes, because they said that the measurements are the same, which means that they are congruent. The two angles are congruent. So what lines are parallel? Is it R and S or L and M? Well, instead of just guessing, look what line is going to be the transversal that's relating 4 and 7. That would be R. So if R is a transversal, the two lines that are in question for being parallel are going to be L and M. So those are the ones we're looking at. So L and M would be parallel by the converse of alternate interior angles theorem. So L and M, converse of alternate interior angles theorem. Most of you guys got that right, which is wonderful. Good job. All right, M and N are parallel, so find the values of X and Y. This one's super, super simple, and most of you guys got it right, which is wonderful. So if this is 112, it's a little difficult because our parallel lines are kind of vertical instead of being horizontal, so it's not how you're used to looking at it. But we know if this is 123, we could solve this many ways. One way we could do it is to move the corresponding angle here, and then you can see how they all relate. Another way, which I would encourage you to try to think about, is what about the angle pair here? Well, these are going to be alternate interior angles, right? They're on the alternate side of the transversal and the interior of the parallel, and the alternate interior angles are going to be congruent, meaning this is going to be 123 degrees. Also, these two here on the top part are same side interior angles, which are same side interior, same side supplementary. So the supplement of 123 is going to have to be, it's going to be what, 57? Yes, 57 degrees. So many different ways you can prove it with alternate interior and same side interior, or if you're not sure, just move the corresponding angle over and you'll see that Y is vertical with it, so it's 123, and X is its supplement, which would be 57. So, and then be careful because I will flip the order on these. That's very common. So make sure that you match them up. So X we said was 57, and then Y was 127. See how this would be backwards for number B? Or for letter B, and that was the most common mistake. So X is 57 and then 123. Oh, I even did 53 and 127. Man, I'm just being really, I'm trying to make sure you're not rushing through it. But that is kind of cruel. I like it. All right, so if A is perpendicular to D, which is perpendicular to B, that's how we read that. So A is perpendicular to D. I'm gonna fill that in real quick. So A is perpendicular to D. They also tell us that A is, and A is also perpendicular to B. Okay. In other words, D is perpendicular to B. That's the same thing here. Sorry. So A is perpendicular to D and D is perpendicular to B. That's how it's read. I'm sorry. And D is also perpendicular to C. So that's going to be the one down here. And E is parallel to D. So we know that E is going to be parallel to D over here. Then which of the following statements are true? All right. So is A parallel to B, which is parallel to C. So A is going to be parallel to B, which is also parallel to C. So we can evaluate that one by looking at the corresponding angles. So if the corresponding angles in the top right are both the same, that tells us that A and B have to be parallel. And then if this one's a perpendicular as well, it's kind of perpendicular transversal theorem, we're kind of working backwards from that. It does tell us that all three of these lines, A, B, and C, have to be parallel. So one is going to be true. What about E is perpendicular to D? So is E perpendicular to D? No, we don't know that. In fact, they're not perpendicular. They said they were parallel. And it's impossible to be parallel and perpendicular. So this would be false. So make sure you don't do that part. And then is E perpendicular to B? So E perpendicular to B. All right, well, if this is a right angle, if these two are parallel, then the top right corresponding angle here also has to be a right angle. That is the perpendicular transversal theorem. So that is true. So the ones that are true are 1 and 3. So 1 and 3 only, which would be B for our answer. And let's see. It looks like most of you guys got that right, so good job. All right, number 18. Lines G and H are perpendicular. If G contains the points here, what's the slope of the line? So you will be given the formula for a slope. So if we want to do this, we can label this the first and the second order pair. So this is the x sub 1 and the y sub 1, and this is the x sub 2 and the y sub 2. Then plug it in. So y2 minus y1, 5 minus 1, and then 3 minus 4. 5 minus 1 is going to be 4, 3 minus 4 is negative 1, and we can write that as just simply, you can put the negative out front, so negative 4 over 1, which is just negative 4. So the slope of line G is negative 4. They want us to find the slope of line H. Do you see how those are not the same? Okay, and what do they tell us about G and H? G and H are perpendicular. Well, what do we know about slopes of perpendicular lines? Okay, so slopes of parallel lines are the same because they are parallel and they don't intercept. Slopes of perpendicular lines are opposite reciprocals. Okay, the opposite reciprocal means we change the sign and we change the order. So if we have -4, we want to change the sign, which is going to be now positive, and then 1/4. So positive 1/4. Okay, so if I graph that out here, these are the 2 points, and we are going to the right one and down 4. So that is the slope of -4. Okay, so the other one we have is going to have a slope of positive 1/4. So if I go up 1 and over 4, that would be this line right here. And that is now a rise of 1 and a run of 4. So 1/4, positive 1/4. And you'll notice these two do intersect at a right angle, just like they always will if they have opposite reciprocal slopes. So what is the slope of line H, which is perpendicular to line G? So it's not going to be the -4, line H. So if this one was G, so that's line G, this is line H over here. Line H is going to have a slope which is equal to positive 1/4. So most of you guys that missed this, you gave me the slope of line G instead of giving me the slope of line H. So you won't make that mistake again whenever you see it on the test tomorrow. So make sure you just slow down, read the question carefully, because that's what it was asking. All right, 19. Are lines A and B parallel, perpendicular, neither? So surprisingly, most of you guys got this right, which means I really emphasize this year because last year I didn't do a very good job of it. And this is one of the most missed problems and one of the hardest concepts for my kids to grasp last year, but not for you guys because you guys are really smart. So we have line A and line B. Now line A is already in y is equal to mx plus b format. So we know the slope because the y is by itself. So the slope has to be equal to 3, okay? Now line B is not, it is, you could call that standard form if you want. So it is in standard form. So we need to solve for the y by itself. So first step, I'm going to move the x to the other side by adding x to both sides. And then I'm left with 2y is equal to x plus 10. Not 10x, because we're not doing 10 times x, we're doing 10 plus x, or in other words, x plus 10. So be careful, very common mistake. Next step, I want to get rid of this multiplication by 2, so I'm going to divide everything by 2, divide all the terms by 2, because we're distributing the 2 through the addition here. So it's going to leave us with y is equal to 1/2 x plus 5. Now that this is in form y is equal to mx plus b, whatever's in front of the x would be, namely the -1/2, has to be our slope. Now, is 3 and -1/2, are those opposite reciprocals? Well, let's see. If we had a slope of 3, what's the opposite reciprocal of positive 3? Well, that would be -1/3. Is that the same as -1/2? No. Well, if we had -1/2, what's the opposite reciprocal of that? From negative to positive, then do the reciprocal, which would be positive 2/1, which is the same thing as just positive 2. And is that positive 2? No, they're close-ish, but they're not the same. So how are they related? Do they have the same slopes? No. So they're not parallel. Are they perpendicular because they're opposite reciprocals? No. Are they parallel since the slopes are opposite reciprocals? No. That logic doesn't follow at all. So it's neither because the slopes are unrelated. They'll intersect, they just won't intersect at right angles. Nothing special. All right, number 20. Which line is perpendicular to the line given here? Now, this is already in slope-intercept form, meaning our slope for this one is going to be -5/6. Okay, so if we want perpendicular, remember that's going to be an opposite reciprocal slope. So we change the sign from negative to positive, and then we do the reciprocal. 5/6 is going to be now 6/5. So we need a line that has a slope of 6/5. So this is 5/6. That's going to be the opposite, but not the reciprocal. Positive 6/5, that's going to be our answer that we're looking for. So that's going to be B as in Bravo, and that's it. So went a little bit long, but I told you guys a super awesome story. I hope it was entertaining for you, and I'm going to give you guys the timestamps for these questions as well in the YouTube video. I'll figure out some creative way to do that so it's not like overwhelming, but hopefully you guys enjoy that, and make sure you guys study. And if you have any questions, you can always join us for our Google Meets. We meet every day, every school day from 11 o'clock to 12 o'clock. Yeah, 11, 12. So look forward to seeing you guys on the Google Meets. And yeah, and maybe I'll be meeting with more of your parents tonight for date night part 2. I mean, parent-teacher conferences. See you guys. Have a good day.